And here we're going to talk about something called display lists. I'm bringing this up because it's used in the sample code and it's really useful. And it's a good efficiency thing too. If you're going for better graphics performance, display lists are something that you really ought to be thinking about. Okay, so let's set up the reason for doing this in the first place. Drawing a sphere is time consuming. So here is some code out of the OSU sphere code. And notice that here's a for loop. And in that for loop are a call to cosine and sine. Here's an inner for loop. And inside that is a call to cosine and sine. Well, that means especially these two calls get executed a lot. And sines and cosines are pretty slow, relatively speaking, to call in your program. So if you're going to draw a bunch of spheres on your graphics screen, you really don't want to call the sphere function every time you want to redraw the scene. It would be really nice if you could encapsulate all the X's and Y's and Z's that you need into a list and then call up the list. Bam, that's what display lists are. Okay? Yeah, that's the rest of the code. Yeah, that's the rest of the code. Okay, so here's what's going on. When you put that sphere in your code, and every time you want to redraw the screen, you call the sphere function, that means all those sines and cosines get called over here, and all of the X, Y's, and Z's gets transmitted across the bus. When you make a display lists are actually kept over in GPU memory. And so, yes, you call the sines and cosines once, you put the XYZ numbers into the display list over on this side, and every time you want to redraw the sphere, you're just calling up the XYZs. Okay? Don't have to use the bus, don't have to execute more sine and cosine calls. So this is a huge advantage in many aspects of computer graphics, and so that's why it's given in the sample code, as you might as well get used to seeing it. So here's how to do it. And you'll see this, there's a function called init lists, and this is the code from that. See, init lists. Um, First, display lists are given a number, and you can give them a number yourself, 1, 2, 3, 4. There's a nuance to that I don't like. And what if you're putting some code together, some of your code, some of your friend's code? What if you both use display list number 2? Well, the second one of you to use display list number 2 is going to wipe out the first person's display list number 2. So OpenGL put in this function called genLists. I just want one nice number that's not used. And that's what genList does, is it goes out to all the display lists that are there and says, give me a number that's not used yet. And really, you don't care what the number is because we're going to put it in a variable and we're just going to use that variable again. So we don't care what the variable value is. If you care, you can print it out. Yep. If you use display list differently, it might change from one running of the program to the next. But okay, so how many unique unused display list identifiers do you want? Here is the identifier we call new list. New list sort of changes the switch on the railroad tracks. That is before every graphics command you gave went to the graphics system. Now every graphics command you give goes to GPU memory. So new list causes that to start happening. Now you go ahead and, well, do what you do. Sphere has begin end calls in it. So you'll do all your begin end calls like you normally would, but they are going into GPU memory, not to the graphics system. And when you say end list, that means you are now done putting things in GPU memory, and the next graphics call that you issue is going to go to the graphics system. Okay, and now when you are in the display function, here's what you do. You say call list, give it the name of the list, and it sucks all those coordinates out of GPU memory and sends them. And the graphics system really can't tell. The graphics system can't tell whether that command, that XYZ, just came from the CPU or whether it came out of a display listed GPU memory. It's great. Now, this has been a common display list misconception from the beginning of OpenGL. I imagine if I'm teaching this course in the year 3000, this will still be a problem. All right, let me set it up. Let's say we have global variables. We'll call them L and W because they're the length and the width of a rectangle we're going to draw. We have a rectangle display list. In a init lists, we set those global variables. Well, we want a length of 10, we want a width of 5, and we now open up the rectangle list and we draw a rectangle using L and W. So our GL vertex 3F calls have L and W built into them. Okay, not 10 and 5, L and W. Now, when we go to use the display list, we're in the display function, we reset L and W to something else and call up the display list. What size rectangle will you see on the screen? Will it be 10 by 5 or will it be 4 by 2? And the answer is it will be 10 by 5. 10 by 5. Oh, thanks for barking all over my video. It'll be 10 by 5. And the reason is when you call those GL vertex 3F calls right here, well, C is a pass by value language. Even though you're using L and W in the function call, it's the numbers that are going over. And display lists bake the numbers in. Over in GPU memory, there are numbers. There is no recollection at all of what the symbol was, what the variable was that that is changing or that created those numbers in the first place. So it doesn't matter at all what you do to L and W because the original numbers are baked into that display list. It'll draw 10 by 5. This comes up especially in animation because what people love to do is they love to put in equations of motion like x equals r cosine theta, y equals r sine theta into a display list and then modify theta, thinking that the object will be going around in a circle, and they're just shocked to find out it's not. Well, that's because it's the numbers that got baked in to the display list, not the variables. Okay, so keep this in mind. This is a common display list misconception. Now you know better, so don't do that.